Have you tried Music to Code By yet? Well, why not? Here's a comment Joe left on the website. This is also great music to mow by. I like listening to music while doing yard work to help the monotony of it seem less tedious. This past summer, I started listening to these tracks while doing yard work, and they worked great. I could let the music play in the background without focusing on it, and it seemed to help me concentrate on getting through my tasks. Thanks, Joe. And now you can download the entire 13-track collection. That's over 5.5 hours of music to code by for only $39. Check it out at musictocodeby.net. Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
I'm recording from home today, my friend. It's a rainy day.
Nice. We tend to do these Geek Out recordings on the weekend, either a Saturday or a Sunday, and a little more laid back, a little more casual.
Exactly.
Which is good. I think it puts us in a good mood for contemplating some of the complexities they're going to dig into.
Yeah, I can't wait.
And folks may have noticed, in fact, people have been complaining that I took a few months off of Geek Outs.
Yeah, and everybody's like, what happened, man?
What happened, man?
Are you okay?
It was just a frantic summer. I mean, there's no two ways about it. You know this because we talk all the time.
Yeah.
We got a lot of our summer shows shot in June, and I just was at a point where there was so much travel, so much going on that it was very hard to get that in there. And for the first time in my life, or arguably in a very, very long time, I'm pressing against the limits of my ability to do all of the research and all of the, between Humanitarian Toolbox and Dev Intersection and the podcasts and the history of .NET, which is, taking a bigger and bigger chunk of time up as I do more of the research to put that book together. It's getting very challenging to put it all on.
It's almost like having a real job.
It's almost like having a job. And plus we've dropped down to 2 shows a week now.
Yeah. And
I was fine when it was 3 shows a week that one a month was a Geek Out.
Right.
But at 2 shows a week, it's like 12% of our shows is Geek Out. It's a little tougher to take. So I am now actively working on a Geek Out website to make a standalone show.
Yep.
I don't know that I'm going to be able to light it up before I finish History.net.
Yeah.
Which is going to go History.net. I want to have in be the top geeky Christmas present for Christmas 2018.
Yeah.
So, but that means I need to be done by summer of next year. So I don't know that we can stand up the new Geek Out site before then, but that's sort of where I'm projecting.
Well, that'd be awesome.
I appreciate everyone's patience. I hate to say this is an easy Geek Out, but we all follow SpaceX so closely.
Yeah.
The latest set of announcements are important, and they represent, the trick with SpaceX is looking at what they didn't say as well as what they did say.
Well, I can't wait to get into it. But first, we have this little matter of a bit we call Better Know a Framework.
Yes, sir. All right, buddy, what do you got?
Well, this being .NET Rock Show 1486, if you go to 1486.pwop.me, you'll find a set of gaming headphones. And I know this is weird, but...
Yeah, because you're not a gamer.
I'm not a gamer, but I am a podcaster, and I do deal with people who aren't audio people or aren't technical and need to interview them on podcasts. And
interesting.
Lately, a lot.
And this is for 2 Keto Dudes, right?
Yeah, 2 Keto Dudes is sort of blossoming into this organization called 2 Keto that is producing more podcasts every week.
Neat.
And so one of them is called the Obesity Code Podcast, obesitycodepodcast.com. Another one is with Mark Miller and Karen Mangicotti called Keto Families and Keto Kids. There's 2 there. And another one with Daisy Brackenhall called Keto Woman Podcast. And so they're dealing with guests, and I'm dealing with guests all the time who don't know anything about recording. And so I needed a solution that was drop dead easy, and this is it. And I tested 4 or 5 different headsets. The whole idea here is that it's USB, it plugs in, and the microphone and headphones become the default audio system, the default audio device. Like there's no preamps, there's no mic stands, there's no windscreens. And so the sound quality had to be really good. And they also had to be closed headphones so that the sound wouldn't leak out. And
right. So you don't get crosstalk.
Yeah, and you'd be surprised at how crappy some of the sound is on these things, especially, $50 or less.
Yeah, and this is an inexpensive pair of headphones. But yeah, I would expect that some of them are quite poor.
Yes, some of them are. And I even got one, not reading the fine print, that it said it was USB. And then I noticed that it also had a microphone cable and a headphone jack. I'm like, what? Well, what's the USB for? You know what it's for? The blinky lights.
Oh my goodness. It was just power.
Just to power the stupid lights.
That is funny.
Yeah. Well, those got returned.
Yeah, you think?
Yeah. So this is Nubwo, Nubwo K5 gaming headset. It works with the PC, the Mac, PS4, anything that has a USB port and does audio. And it sounds really good. And I have no problem at $34 because I've got Amazon Prime just sending a pair all over the US and from this person to that person to that person to this person, or, so if you're going to be a podcast guest and you want a drop dead easy microphone setup that you can just use with Audacity, which is free, check that one out. Personally sanctified by me.
Yep. You checked it the old-fashioned way. You tested it.
I tested it. Yeah. Yeah.
Love it.
So who's talking to us today, Richard?
Grabbed a comment off of show 1115. That's the space-based Power Geek Out.
Right.
Which I was going fairly far back in the catalog. And there's lots of different comments. And I always have great discussions around these shows. And I tend to write long responses to folks at times. This is all the way back from March of 2015. And the comment is not actually about space-based power either. This is from Paul Schrum, who's been a listener to the show for a long time.
Absolutely. We know him.
We've gotten a few emails and things from, but I don't know that he's ever gotten a mug. And he, here's how long ago it was. He starts off the comment by saying, I can't figure out how to get into Google Moderator.
Oh, wow.
Which has been gone for a while. It used to be the way that I built the list of what show to make next. But I found this comment fascinating, even though it's 3 years old, just because it sort of touches on so many things that have evolved a lot. And so, I mean, a bit unfair because it is 3 years later, but it's just, I think Paul was thinking really well about what was hard and what was easy and what was coming. And so his comment goes, I am thinking your audience is interested in intriguing, emerging, and almost there technologies in our present reality. I totally agree, Paul. That's exactly what folks are excited about. It's what I'm excited about as well.
Yeah.
And so there are a few things you mentioned around artificial intelligence, like artificial consciousness or sentience. Or do we go into the new expert systems that could all be on the list? Not an expert in AI, but there's, many areas to explore here. And again, how prescient is that 3 years later, when it's all around us? Yeah. And the AI show we did a couple of years ago is just nowhere near what's actually going on. Right. So he digs into these particular elements that I made notes on from this comment back then that these were good ideas. Such as SLAM system. SLAM is an acronym for simultaneous localization and mapping, aka the key technology necessary for autonomous driving. Okay. Right. And really that's about how do you take 3D imagery, so stuff from a LiDAR, that little rotating dome that builds up that 3D representation, and then deal with it. Right. Figure out how to work with it. And what's fascinating now is the sensor in question here, that LiDAR, those used to be tens of thousands of dollars. They're now down to hundreds of dollars. Wow. So and even then, because of the increase in AI technology, machine learning and so forth, we almost don't need them. That multi-optical systems are doing great 3D renderings without having range finding like that. Yeah, right. Next up, neural networks. What are they really? And it's funny that neural networks, very much an 80s technology, are right back. We call it deep learning today. Right. But they're essentially the same tech. It's just that everything's faster. The learning models are smarter. There's so much more data available because of where the internet has gone that technology is sort of back. And neural nets, if I'm not mistaken, are really good at finding patterns that humans just would not be able to find. And doing inference relationships. One of the early neural net techs that I worked with was a bottle implant where they were looking for flaws in bottles. And so no two bottles are flawed the same way. How could this thing possibly find that? It's those strange inference that neural nets really show up their capabilities.
And you don't necessarily answer the question, why does this happen? But you do answer the question, when will it happen again?
And when you see it again, right? Those variations are very tolerant. And it's one of the challenges around neural networks today is that it's so non-deterministic. It's so difficult to know why it decided the thing it decided that there's a strong case for strict limits on the importance of neural networks, or where they can't really make life or death decisions, because when they make it wrong, you simply won't be able to answer the question, why did it make that wrong?
Yeah.
So very challenging. Paul goes on to mention robotics. When can I be Anakin Skywalker and build my own robot from spare parts lying around? Yeah, that's one of the... Don't watch episode 1. Come on, man. It's not worth it. Just don't do it.
It's so bad.
and he mentioned stuff like Netduino and so forth.
Yeah.
The best place that I see today for sort of smart robotics are the autonomous flying systems. So more build your own drone.
Yeah.
So much of the complexity of flying has been absorbed in these standardized chipsets now. And I pointed stuff like the DJI Spark as just a different level of drone where it handles its own hovering. You let go of the controls, it stops flying and just stays where it is. Like so much smarts now. And all those things are available as parts. So you can build them the way you want to build them.
Wow.
Natural language processing, and he references your old DNR TV on speak recognition with the Kinect.
Yeah.
And it's funny how that's evolved too. We were stuck at sort of the 90% accuracy range for a long time with NLP, and then suddenly jumped up into the 98, 99%. And it was because literally it was a redesign around cloud-based compute. Remember when you had to train voice systems?
I do. Yeah. And you still do if you want them to really be tweaky, but some of them are really, really advanced. Like when they don't understand something, they go to the internet.
Yeah.
Well,
you're right. But when you think about, nobody trains Siri anymore, nobody trains Cortana anymore, nobody trains Alexa anymore.
Right.
And that's the new model that's so much smarter. And I don't, it's a geek out to talk about how this has changed, this sort of transformation, which is certainly interesting for me.
Yeah. Well, we talked about that on the show before. When you have a service in the cloud like that, you're providing the service, you only have to tweak one speech recognition module. You only have to tweak one algorithm, and you train it, and you constantly train it. So though if you're using it last year, it's this year that much better because it has learned so much.
Yeah, I wonder if we simply hit the good enough phase now that we stop thinking about it. This is no longer exotic. It just kind of works. And I think the introduction of Alexa and the spread of Alexa, which clearly is the dominant tech in this space right now, sort of shows that we've crossed the line on this. And Paul finished off by saying all of these are interrelated in various ways. Yeah, there's a lot of AI behind everything going on there, even though I hate the term. That's the blanket term these days.
Yep.
Those of us recall our reactions when the first Apple II came out. Many of us wanted to hear more about how cool this stuff is going to get, that we might get on board and do some of it ourselves.
Yep.
Paul, can't argue with it. It may take me 3 years to read your comment, but I said 3 years ago, I made notes on some of your thoughts here because they are potential shows. And as I go forward, starting to think about what the Geek Outs will look like standing on their own instead of part of .NET Rocks, things are going to have to be different. And I don't know what the outcome will be. I'll be willing to experiment. You guys will have to come along with the ride and tell me what you like and what you don't like.
Definitely.
But these are topics that are absolutely worth talking about.
Yeah.
And so, Paul, thank you so much for your comment. A .NET Rocks mug is on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we've published every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a mug.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. We let our dogs play with them.
You don't have a dog.
Hey, come on. Why let the truth get in the way of a good story?
I love that line.
Yeah. And by the way, how I got there is because I was going to do something about drones. And I just know that people who have drones and dogs have a particularly good set of things to play with.
Although the two don't get along very well.
I just wanted to let you know how my thinking went there at lightning speed. That is the science of funny, my friends.
There you go.
I guess. So let's do that. Let's get into SpaceX and all of the new things that have been announced and have been achieved. Quite frankly, it's pretty amazing to me that a rocket can fly into space and land vertically in the middle of the ocean.
Right.
And be reused.
And has been reused.
And has been.
It's been a year. Last October's show was about the SpaceX interplanetary transport system. So, and again, it was the same thing. And that this particular conference that Elon goes to every year, he tends to make these big announcements. And so, in a year, he's done a ton. I mean, he's flown so many Falcon 9s. He's landed them reliably. He's landed them. And, for me as a geeky space guy, what do I watch for? He was able to land polar orbit.
Yeah.
So flying out of Vandenberg, where they actually take off going south because they're going to do a polar orbit. He was able to land the first stage on the ship there. He's able to land the COTS mission, CRS, resupplying the space station. That's an easy one. It's a funny inclination, but it's lower power, lower altitude, very precise flight. Those are the ones you see. They tend to fly them back and land them back on land. He's also been able to land geostationary orbit launches, which are much higher energy because they have to go substantially higher boost. And so tougher to return. Those are the ones that tend to return on ships.
Geostationary orbit means that it's in sync with the Earth. So
with the rotation of the Earth. So 22,300 miles up or 36,000 kilometers up.
And if you were to look up and see a satellite or anything in space that was in geosynchronous orbit, it wouldn't appear to move.
Right.
Yeah.
They would move. Well, yeah. They're really hard to see because they're a long way away, even though they're relatively big satellites as satellites go. And they just don't whiz by like the space station does,
right? Or
any of the low Earth satellites, like the Iridium cluster. If there's people who like watching for those, they're relatively small satellites, but there's 36 of them, so they're always buzzing around, and you can see a flash from them on a good dark night,
right?
So those types of missions, that array of missions speaks volumes to how well he's got things wired in with the Falcon 9. In some ways, I think the Falcon 9 is pretty much as developed as it's going to get. And one of the questions I had a number of years ago, back at the beginning of doing Geek Outs, was what would he do different on the rocket if he knew it was recoverable? Yeah,
that's a good question. And just to get back to the recoverable thing, that he's done it. The space shuttle was supposed to be recoverable and reusable, but did they ever reuse one?
Well, absolutely. They flew the shuttles multiple times. The problem was that, and the main thing they wanted to recover were those engines.
Yeah.
And it's I was reading more about the SSME, the space shuttle engine, the other day. They only built 42 of those. Those engines. They used it in clusters of 3. All of those engines were repeatedly reused. And arguably the shuttle is the size and shape it was to get those engines back. That was the really expensive bit, as well as the spacecraft itself. But the engines were super important. And they still have most of them. They're going to fly them on the SLS.
It took them a long time to re-prepare them, though, for...
Yes. The fastest they ever turned around a shuttle, which was like an emergency sprint, was like 90 days.
Yeah.
Normally, you would be lucky to fly a given shuttle more than once a year. And the reason was that the tile system needed a ton of maintenance.
Yeah.
And as the spacecraft started to age, inspecting, because there were so many failure modes that were not survivable, ways that the ship could break that would kill the astronauts and lose the vehicle, inspections were hugely extensive. And so it was tens of thousands of hours of inspection, refurbishment, repairs for every flight. And that's really what broke the back of shuttle. They were trying to do too much.
Yeah, but Elon's not putting people on a Falcon 9, so he's not under that kind of pressure, is he?
Well, he hasn't yet. The next Dragon, the Dragon crew, is supposed to be flying people to the space station. The Falcon 9 full thrust is in the power range and capability to absolutely bring astronauts to the space station.
Wow.
And he's ready to test that. In fact, in the past year, there's been a bunch of changes around exactly that issue. And I'll talk about him in a sec. I want to talk a little bit more about Falcon 9 because he did announce a couple of changes he wants to make to Falcon 9.
Okay.
One of the few things that I could see clear evidence that he modified now that he knows he's going to recover the and reuse the actual first stage is those paddles, the little fins that sort of pop out at the top of the rocket to help guide it in.
Yeah.
The original ones were made of aluminum, and on a few occasions you could see them all but melting at times when they were coming in at higher speeds.
Huh.
They've been replaced with titanium ones.
Wow.
Titanium is lighter than aluminum, but not by much. Much more heat tolerant, but substantially more expensive.
Yeah.
And so it makes sense once you know you're going to reuse a rocket to say, I'm going to put the more expensive but more long-lasting part on. So that's
Sure.
one of the examples.
Yeah.
But the craziest announcement about the Falcon 9 that came out in this last wave in September is that he's going to take off the legs.
What?
So you know those fold-out legs that for the landing?
Don't they help him land?
Yeah, why? Yes, they do.
Oh, why
He's
take them
now
off?
in a place where he feels they're so precise on their landing, they know exactly where they can put the ship down, that they want to land the Falcon 9s back on their pegs. So there are 4 structural pegs at the bottom of the ship that are what the rocket sits on when it's on the pad.
Okay.
And then when it takes, because the legs are folded up when they take off, right?
Right.
And so those little pegs, and they're only a few inches across,
Oh, wow.
sit on posts that keep the rocket stable so that it can be moved to the pad and they lift off directly from that. So he's now in a place where he says, we're so precise in our flying that we think we can put it back down on the pegs.
So that's kind of like if you have patio furniture and you got a table with a hole in the middle that your umbrella goes into.
Right.
That's the kind of precision he's talking about, isn't it?
That is exactly the kind of precision he's talking about. But remember, you're taking a patio umbrella with one post. This is a 25-story tall building with 4 posts. So you had to get the rotation and alignment exactly right, because you miss it all, it's going to tip over.
What if there's wind? I just don't see how this is going to work. I can't even put my patio umbrella in if it's windy. How is he going to do that?
I don't know. And I don't know that he's actually going to do it. I mean, one of the things, now that we've spent time with Elon, it's been a few years. Yeah. He says some crazy stuff, and then often he has to dial it back. And I feel like he was running out of things to say about Falcon 9, that so much worked so well on Falcon 9 that this is the only thing he's got left. And admittedly, if he takes the legs off, that's weight that gets to go into payload. So it'll, in a lot of ways, the Falcon 9 full thrust has been tweaked to the limits of that design, and there's not much further to go on it.
Yeah.
And so this is the only thing he's got left to really improve on.
Yeah, I suppose you're right. I mean, and as crazy as he is, I mean, it's the dreaming and the thinking big and then scaling back that gets him to the best reality he possibly can get, I suppose.
And you said it so well, my friend. In fact, if there's anything that comes from this particular Geek Out, it's that statement. What we get this year over last year is a more detailed analysis and a reimagining of proposals from the previous year, closer to reality.
Right. Yeah. Well, hold that thought right there, Mr. Campbell, while we take a minute to hear a word from our sponsor. This portion of .NET Rocks is brought to you by our friends at JetBrains. Hey, how often do you profile memory usage in your .NET apps? What if you could automate memory usage checks so that they're executed every time you commit a change? You can actually do that with .memory unit from JetBrains. .memory unit is a free unit testing framework for monitoring .NET memory usage. You write unit tests that check your code for all kinds of memory issues, and then run the tests on your machine or in a continuous integration server like TeamCity or VSTS, just like you do with regular unit tests. You can track how much memory is allocated, check memory for objects of a specific type to prevent memory leaks, or compare several memory snapshots in a unit test to see if memory usage is creeping up. Learn more and download .memory unit from jetbrains.netrocks.com, or just search for a package called .memory unit on the NuGet gallery. And we're back. Carl Franklin, Richard Campbell, we're geeking out about SpaceX. Richard and I were just talking about Elon and how his thinking big and dreaming is necessary to allow his people to get to the best reality they possibly can. that's closest to his dream.
And he seems to get more and more honest about what he's doing. He often talks about this is an aspirational goal or an aspirational date.
Yeah. Boy, it must be fun to have his job.
But he balances a lot of balls at the same time, right? It's very challenging.
Yeah.
Something we talked about last year and have talked about before was with that new version 2 of the Dragon, the Crew one. There's a great video, and I'll include it in the links, about the V2 when it re-enters the atmosphere. It's going to land on land. They actually have engines, Super Dracos, they call them.
Yep. Okay.
On that. And what was clever about its design was not only were they for retro propulsion for landing, they were also the escape system. And he's tested this. Yeah. So that should something go wrong with the rocket, you're able to pull the crew off the end of the rocket and fly them to safety.
Wow.
And so where with the SLS and the Saturn V before it, there was an additional rocket engine sort of stuck on the top of the capsule that was a pull-off system, but normally you wouldn't use it for anything. It's only in emergencies. Although later versions of the Saturn V, they actually used it for a little bit additional thrust before they threw it away. Here was this design that said, here are these engines and we're going to use them every time. Either we use them on the emergency during ascent to escape or we use them for landing. And if you watch this video, it's like a 2-minute video. It shows right at the end, it doing a landing on a pad with little pop-out legs. And there's a couple of problems with that. And this has sort of come to a head now that they've actually abandoned this design and this intent almost entirely. The first problem is those pop-out legs come out through the heat shield. Oh. And so that creates a weak spot in the heat shield. Now, I'm not saying it's insurmountable. I'm saying these were issues that NASA brought up as they're going to need a lot of testing to be able to prove that this is safe. And the same goes with the Super Draco engines. Those are hypergolic engines.
Hypergolic?
So yes, hypergolic engines. Great term.
Okay.
Normally so hypergolics speak to their fuel, right? This is nitrogen tetraoxide. So rather than using cryogenic fuels or anything like that, these are the fuels that as soon as they touch each other, they burn violently. And they're super toxic. So if you remember, hypergolics are usually used for RCS, for the maneuvering system, to be able to point the spacecraft the way you want to.
Okay.
And because they're so toxic, whenever you saw a shuttle land, the astronauts couldn't get out right away. First, a vehicle would come up and guys in bunny suits would carefully vacuum off any traces of those hypergolic fuels that might be stuck to the ship because it's so poisonous.
Wow.
And so tanks of this stuff in a place where humans are makes NASA nervous.
Yeah.
Now, it's not unprecedented. The lunar module, the part of the Saturn system, the Apollo system, the lunar lander that landed on the moon and then took off again to take the astronauts back to the command module, that was all hypergolic fuel and single mode failure too. If either of those engines didn't work, the astronauts weren't going to survive.
Yeah.
And I think it's one of the reasons that they were fairly keen to retire the lunar lander and shut down the Apollo missions, was that sooner or later, one of those things was going to fail and there were no recoverable modes for it. So, and again, NASA's not saying you can't do it. NASA's saying the bar you need to get over to make those hypergolics reliable enough to be a manned system were high enough that Elon said, we're just not going to do it that way. It's not worth the pain.
Yeah.
And I want to point to each of these decisions because it leads to the new BFR.
And BFR stands for?
The Big Friggin' Rocket.
Are you serious?
That's really the name. You call it the Big Falcon Rocket if you want.
Okay. That's more sane, but okay.
Big Frackin' Rocket? Yeah, no, that's really the name. They should probably come up with a better name.
Frack that guy.
But that name's pretty funny.
That is pretty
enjoyable,
funny.
But it says a lot about SpaceX and Elon, and that's the name.
I like it.
They for a long time when he was working, he was going through the Falcons. He made a Falcon 1. He proposed a Falcon 5. It would have 5 engines. Then he went to the Falcon 9. It has 9 engines.
Yeah.
And he always talked about Falcon Heavy, which we probably should talk about as well.
Yep.
And then there was this aspirational rocket he called the BFR. And last year he called it the Interplanetary Transport System, right? But that was the code name for that was BFR. And BFR is back and different from ITS. going to spend a little bit of time with Falcon Heavy. Falcon Heavy is supposed to be 3 Falcon 9 side by side.
Right. We talked about this.
Sure we have. And the original proposal on it was so simple. We're just going to strap 3 side by side. We're going to cross feed the fuel so that the outer tanks feed the center engines as well. Now you're going to have 27 engines instead of 9.
Yep.
And you're going to go. Then the outer boosters will empty first because they're feeding all these engines. Then they'll peel away and go back and land to be refueled and reused. And the center stage will still be fully fueled. So you'll get this huge boost. So where Falcon 9 full thrust got to 22 metric tons to Leo, the Falcon Heavy to do 54 metric tons, which just put it in a different class.
Yeah,
they
right.
figured they could get 13 metric tons all the way to Mars.
Is that what they were building it for? With the idea in mind it would go to Mars?
It was 13 metric tons to Mars would be more mass lifted to Mars than has ever been lifted. You know, the largest thing to be sent to Mars was the Curiosity rover at 1 metric ton. Well, it's not true. It was 1 landed. It was 5 with all of its flight gear on it. And it put a metric ton on the surface.
Wow.
And he was proposing 13 metric tons to the surface, which is extraordinary.
Unprecedented.
And probably not going to happen.
Okay.
Again, as the technology continued to advance, as they started to really build Heavy, and they're building Heavy, they will attempt to fly Heavy.
It may just not be as heavy as they originally wanted.
Well, and this is the thing that happened, right? So the cross-feeding of fuel, that's been deleted. They'd love to do it at some point. There's no plan to do it. And there's a good reason for that. It's really hard to do. It's unprecedented.
Okay.
You know, those turbo pumps on each one of those Merlin engines are spinning at an incredibly high speed. They need a very stable fuel flow. If you have a burp in the fuel flow, those things blow apart.
Yeah.
So the idea that you would change the flow from one tank to another while it's running, just too dangerous.
Wow.
And nobody's done it. The Delta IV Heavy, which is the closest similar rocket to the Falcon 9 Heavy, it being also 3 side-by-side tanks, all with these RS-68 engines, they don't even try to cross-feed. The way they work is the center engine, they all take off at full power, and the center engine throttles back to 60% after a certain amount of time, so that the outer's empty first, and then the center still has enough fuel to fly a bit further, get a higher lift.
Wow.
Until the Falcons came along, that was the heaviest lift rocket the Americans had, was the Delta IV Heavy.
Huh.
So deleted the fuel crossover. A number of times he's now said, wow, this turns out to be harder than we thought. The center column has so much stress on it because the 2 outside rockets are pulling on it. They had to redesign big chunks of it. So the center is very different from the outboard tanks.
Okay.
And then when he was asked about Heavy again, he said, you know, we're going to fly this thing, but we've hit a limit on what we're able to test on the ground, and we just don't know whether it will make it to orbit. I'm hoping, this is literally the quote from Elon, I'm hoping it doesn't damage the pad.
Wow. Well, guess what time it is, Richard?
It must be that happy time again.
You got it. It's time to remove the umbrella of sanity from the patio table of conversation, allowing the inane winds of stupidity to blow over the furniture.
That was awesome.
I thought you might like that.
I love everything.
It wasn't funny, but it was awesome.
But it was awesome.
It's actually time to give away a D-Experience subscription from DevExpress to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries, and deliver elegant .NET solutions that address customer needs today, and leverage your existing knowledge to build next-generation touch-enabled solutions for tomorrow. Whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best, without limits or compromise. And check out their DevExtreme React Grid, built from the ground up to fully support all the cool features that come with React, like the virtual DOM and state controllers like Redux. It supports master detail, sorting, grouping, paging, and editing. You can check it out and test it for free on GitHub. Learn more and download your free 30-day trial of DevExpress Universal at devexpress.com/superhero.
Well, all right, buddy. Who's our winner?
Today's winner, Richard, is Wendy Turner.
Ah, congratulations, Wendy. Golf clap for you.
Yeah. And Wendy just won the D-Experience subscription, a big pile of awesome from our friends at DevExpress, just for being a member of the .NET Rocks fan club. And if you don't know what that is, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world. In every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of said fan club, but you got to sign up to win. So, Richard, didn't they already destroy a pad?
Yes, it did, actually. The SLC-40, the second failure ever of a Falcon 9. So the first failure was the CRS-6 mission, where the second stage blew apart because of a helium leak.
Right.
On the way up. And they would have recovered the Dragon if they'd written the software that said, hey, the ship's blowing up, pop the parachute. Which apparently they've now written. So if that ever happens again, or something like that happens again, you might even get Dragon back.
Wow.
Which is interesting. The second failure was an on-the-pad failure. Okay. Also, the helium system on the second stage erupting, and it burned the pad badly.
Wow.
Destroyed the transporter erector launcher system, and they've been repairing that pad ever since. That pad was supposed to be for Falcon Heavy, but while it's being repaired, they've been modifying 39A to fly Falcon Heavy. And I suspect they'll delay Falcon Heavy until 40 is working again, just in case they do have an explosion on the pad with Heavy that destroys 39A. And 39A, I mean, is the most historical pad of them all, right? Yeah. That's where Apollo 11 took off from. That's where the original space shuttle took off from.
Yeah.
Like, it's kind of an important pad. It would be bad to blow it up.
Yeah.
But my best guess for why they're so uncertain about what's going to happen with Heavy is that there's going to be an acoustic interaction between those 27 engines that pretty much can't be modeled. They can't really figure it out in advance. And so it's entirely possible that the forces involved here could rip the rocket apart.
Wow.
When the first shuttle went up, they had underestimated just how much force was involved. It tore up the pad. It blew down fencing. It damaged a lot of things. They eventually developed a water injection system that sprayed water all over the pad to help absorb some of those acoustic waves to sort of break that down. And that's a very normal thing for them to do now on all pads, is to spray water all over the place to manage those shock waves. But as you get to bigger and bigger rockets, and remember, we're still not talking about the big rocket yet.
Yeah, right.
You just talk about Heavy. I don't think they've done enough to really work through what the acoustic signature of this rocket's going to be. And I think that's part of their concern, is they just don't know if the forces involved, whether it's the pressure of the outboard engines pushing upward, the acoustic waves between the engines that are all in line, that may well rip that rocket apart. And so Elon literally said they hope they're far enough away from the pad before anything dramatic happens.
Yeah. Okay. That makes sense.
Alongside this situation, the main missions of Heavy, there's a few commercial missions that have been proposed that folks are interested in taking, but the famous ones are the Red Dragon.
Yeah.
That's sending a Dragon to Mars.
Okay.
That's indefinitely suspended. Between the no supersonic retro propulsion landing system with the legs and so forth, not doing that, and Falcon Heavy being delayed, they're not planning on flying anything to Mars at this particular moment.
All they really have to do is tweak the transfabulator down a few millirods.
And they'd be fine.
What's the matter with those people?
The other mission we had last year, they were talking about last year, was a private pass around the moon for a couple of wealthy people.
Yeah.
And that also depended on Heavy and the Dragon V2. So that's been postponed indefinitely as well.
Okay.
And I hope you're getting a sense, it's like 9 has sort of gone as far as it can go. Heavy has serious problems.
Yeah.
And so now it makes sense to talk about the updated version of BFR.
The BFR.
Right. Because it's actually the replacement for ITS.
And ITS?
So that's the Interplanetary Transport System. That's what he talked about last year, and we immediately did a show on it, literally a year ago.
Yep.
When that was the enormous rocket, the crazy enormous rocket.
That was big FFR.
Yeah. It was that rocket 12 meters in diameter. So the Falcon 9 is 3.7 meters in diameter.
Okay.
Saturn V first stage was 10 meters in diameter. The proposed ITS, 12 meters.
Wow.
36 feet. Just incredibly big.
That's huge.
But even after, not long after it proposed it, it's sort of reality set in. Like starting with number one, it won't fit in your construction building. Like you're not going to actually be able to build it that big.
Details.
Yeah, it's just so large. And it was, of course, dependent on the Raptor engine. And in the past year, the Raptor engine has come a long way. But it's, again, interesting when I pull all the data together about the Raptor engine. So this is the methane liquid oxygen engine.
Right.
And while nobody has made a methane engine of orbital class, there's been small methane engines. It's very interesting that both SpaceX and Blue Origin, Jeff Bezos' company, suddenly started on orbit class methane engines. Why hadn't they come before? And so, we've talked about this before, but quick discussion on rocket fuels. So the Falcon 9, the Saturn V first stage were RP1, or refined petroleum, jet fuel, and liquid oxygen engines.
Yeah.
RP1 is liquid at room temperature. It's easy to handle. It's very dense for the amount of power it's got. So you have smaller tanks. It's not as efficient. It doesn't burn quite as well. But that's okay because it's dense. So your stage gets to be smaller. It's good stuff for first stages. And it's the only fuel that SpaceX has flown is RP1 LOX.
Right.
Now, at the other end of the spectrum, you have hydrogen and oxygen, right? Liquid hydrogen, liquid oxygen. So this is what the space shuttle used with all of the complexities. Liquid hydrogen is very low density. So the tanks are 8 times the size of an RP1 tank for the comparable amount of fuel. Very efficient, like the most efficient engines you can get, but the tanks are so big, it makes it tough to use.
Yeah.
And liquid hydrogen is much more difficult to keep cold than liquid oxygen. Much more.
Right.
Also, the hydrogen has nasty habits. It tends to bond to metal and it causes what's called hydrogen embrittlement. It's super hard to handle. And so, Elon came out very early on saying no liquid hydrogen, and most people steer clear of it. It's a very tricky fuel to use.
And that might also be a clue as to why the hydrogen economy never really took off. Remember the promise of that in the George Bush years? Yeah.
Yep. And with fuel cells and so forth. And handling hydrogen is really hard and dangerous.
Right.
Fuel cells are expensive. I mean, we still make them. The shuttle depended on them, but they're rare and costly. Yeah.
It also costs more to separate the hydrogen than it does to sell it.
Yeah, it's very tough stuff. So, the inexpensive way to get hydrogen is to actually crack it from hydrocarbons, which means you're basically extracting oil to make hydrogen for your hydrogen economy.
Yeah.
Like, woo.
Wait a minute now.
So the old Raptor, the Raptor's been worked on since like 2012. In fact, at one point, it was just an upper stage engine that the Air Force wanted.
Yeah.
And then as they started talking about it in the context of a really big rocket, there were proposals for a 1 million pound thrust engine. At one point, even a 1.8 million pound thrust engine. The old F1 from Saturn V was a 1.5 million pound thrust engine and the biggest engine ever made, like just in a league by itself, so powerful.
Yeah.
Most of the time when you talk about orbital class engines, you talk about 500 to 700,000 pounds of thrust. So just crazy, crazy powerful engines they were talking about. But in 2016, last year's announcements, they dialed it back a bit. They said, we're going to use methane because methane strikes this nice balance. You can cool it with the same systems that you cool liquid oxygen. It's naturally gaseous, so it's self-pressurizing. One of the challenges with RP1 is you need those helium tanks to pump helium into the fuel tank for the RP1 to keep it pressurized.
Yeah.
And if you notice, the 2 times the Falcon 9 has been lost was the darn helium tanks.
Yeah.
So getting rid of that helium is a feature. You don't need to do that with liquid oxygen because it's self-pressurizing. As you turn the liquid oxygen back into gaseous oxygen, you just feed it back in the tank to keep it pressurized. Methane works the same way.
Okay.
Same kind of cooling as LOX, same kind of self-pressurization. It's more efficient than RP1, not as efficient as hydrogen. Its tanks are about twice the size of RP1, but a quarter the size of hydrogen. So it just fits in the middle very nicely.
Right.
Couple of downsides to methane. One is it runs very hot. So you have to build a beefier engine, right? Which makes the engine more expensive. Now, if you have a single-use engine, that's not a feature. But if you have a multi-use engine, who cares?
Right.
Right? It's actually a feature that you have because it's very clean burning, right? RP1 also has coking problems. It leaves carbon soot and acids on the bells of the rocket engine. If you're going to reuse them, that's kind of a problem. And methane is a simple compound to be made in other locations, for instance, on Mars.
Yeah, it's also storable and transportable.
Yeah, it's a lot more. It's if you have to handle liquid oxygen anyway. All of your handling methodologies for liquid oxygen apply to methane.
Yeah.
So it makes total sense. So in 2016, the proposed engine for the Raptor was a 690,000 pound thrust engine. That is powerful, but not extraordinary. About 3 meganewtons of thrust. And an ISP of 334, which is very efficient. The chamber pressure is going to be 300 bar, or about 4,400 PSI. That is, again, an extraordinary number. 3 times the chamber pressure of the Merlin 1D.
Wow.
And they were also going to do what's called a full flow staged combustion engine. Again, now, what does that mean?
Yeah, what is that?
So you need a pump to pump your fuel into your engine in the right ratio fast enough to give you the thrust you want, right?
Okay.
There's a bunch of different ways to build a pump. The simplest pump is what they call a gas generator cycle pump. So gas generator cycle pump is what they use in the Merlin 1D. They take a little bit of the RP1 and a little bit of oxygen. They burn it to spin the turbine and they pump the exhaust out a pipe overboard. And we showed videos of this one previous times we talked about this. You saw it as this little black sooty plume that came off the side of the engine as it was running.
Right.
Simple, reliable, not especially efficient. Because you actually have 2 different fuels you're trying to pump, both the RP1 and the liquid oxygen, and they don't pump exactly at the same rate. So if you have one pump for both, you have a bit of an efficiency problem. And so they talk about being a fuel-rich mixture or an oxygen-rich mixture, depending on the way you want to build your engine.
Right.
Both have pluses and minuses, but you're trying to keep that pump light and simple as possible. The gas generator is the simplest way to go. Now, there is flow combustion, where you actually take the byproducts that you burn there and pump them back into the combustion chamber to burn. Now, they're already partially burned, so they're going to burn differently than the raw fuel. So it's trickier to build, but it makes a more efficient engine.
Sure.
So the RD-180, the engine that the Russians built, that flies the Atlas V and has caused all this fuss because it's a Russian engine flying American military missions, has that kind of engine. It's an oxygen-rich staged combustion engine. And it is, without a doubt, a more efficient engine because of that. The concept of a full-flow staged combustion engine has not really been built in meaningful numbers. The Russians had an engine called the RD-270. It was along these lines. NASA experimented with it because with a full-flow staged combustion engine, you actually have 2 pumps, one for the oxidizer, one for the fuel, with 2 pre-burners. So it's a bigger system, but it is optimal efficiency. So you're maximizing the yield.
What does a pre-burner do?
The pre-burner is what actually superheats the fuel to turn it back into the gaseous form and as hot as possible so that it burns as efficiently as possible in the chamber.
I get it. It's like pre-processing any other kind of manufacturing material. You want to get it to a state where once you put it in the chamber, it's going to
good to go.
Rapidly combust.
And the closest the Americans had got to an engine this complex was the Space Shuttle main engine, where it had dual pre-burners, but it had a combined pump system. And it was very efficient. It used liquid hydrogen, which is tricky to work with.
Right.
The engines were very expensive. They called them Ferrari engines for a reason. And that's why they wanted them back. And they reused them successfully many times. They actually improved the engine so that it had higher thrust in its original design. Like, there was a lot good about that engine. They now call it the RS-25A, and they're going to use them up on the SLS, supposedly, the space launch system that NASA's using as disposable engines.
Cool.
For better or worse. So that's in 2016. Back in 2016, they demonstrated a run of the full flow combustion engine. Now, it turned out it was a 1/3 scale model of that engine. Now, 1/3 is still a pretty sturdy engine. You're still talking 250,000 pounds of thrust, a meganewton of power.
Yeah.
But it did demonstrate the full flow system working, and it ran. Now they just had to scale it up 3 times to meet the goals. Now, they didn't talk about this at all in the 2017 announcements, but they talked about the Raptor, but they didn't mention the differences between what they talked in 2016. So in 2016, it was supposed to be 700,000 pounds of thrust, 3 meganewtons. They'd only tested a 1 meganewton, a 250,000 pound. In 2017, the new engine, that they're still calling Raptor, is smaller all around. So their sea level engine is expected to be 1.7 meganewtons, or roughly 400,000 pounds of thrust. Still efficient. And what's interesting about that is that means that their scale engine, it was originally 1/3 scale, is more like 60%, 70%. So they're actually pretty close to really building a Raptor engine.
Wow, that's promising.
It is. It's more in realms with something that can actually be made, that they actually have made. They've reduced the chamber pressure a bit, although they think they can get back up to the 300 bar. They're saying 250 bar. For rocket engine people, the most outrageous thing they're saying about the Raptor engine is 20 to 100% throttle ability.
Okay, what does that mean?
Normally, rocket engines work efficiently at full thrust, full bore, right?
Oh.
But this is a problem. You want to be able to throttle them down, and it's really hard to throttle a rocket engine.
And be efficient.
Well, and not blow up, actually.
Yeah, okay.
Because when you get to these 500,000 pound thrust engines, burn stability is really tricky. And so when you cut back the fuel flow, you destabilize the burn, and it can cause chuffing or a bunch of other behaviors that can easily blow the engine apart.
Wow.
And it's one of the limitations of the Merlin 1D. We talked about this. Every time they land one of those first stages, they're doing what's called a suicide burn. Because they cannot run the engine low enough to hover the first stage. At its minimum thrust, it will actually make the stage go up. So they time the burn so that they're decelerating so that the point at which it touches the deck, it's not moving. It's that close.
Okay.
That's a suicide burn.
All right.
And so supposedly the Raptor, by being able to throttle all the way down to 20%, the 1D can't throttle below 50%, which is super normal. That's the way rocket engines usually work.
Okay.
They're saying they're going to be able to throttle down to 20% in a 500,000 pound thrust engine. Unprecedented. But if they can, then it makes the landings a lot simpler. And
this is the engine that they're going to use in the BFR?
That is correct, sir. The new BFR.
The new BFR.
The ITS engine so the ITS, the one they talked about last year, the much bigger rocket, the 12-meter diameter rocket, was going to have 42 of the 2016 Raptors, the 3 meganewton Raptor engines. And 42 was not an accident.
Yeah, right. Thank you,
There's
Douglas Adams.
always good space references. Everything that Elon does is funny this way. So, BFR 2.0, the 2017 edition of BFR, they've gone down to 9 meters. Now, 9 meters is still enormous.
It is.
Just huge, but not as big as not 12 meters. And again, the Saturn V was a 10 meter first stage. The upper stages were smaller. The first stage was 10 meters, so not unprecedented.
Okay.
They're going to use 31 of the new Raptor engines.
Wow.
So that's a lot of engines.
Yeah.
And again, a little on the unprecedented side. The only other vehicle with that kind of engine count was the Soviets' N-1 moon rocket, which had 30 main stage engines and never made it to orbit. Now, I've read a lot about the N-1 as now that more information has been released about it, and it wasn't just the engine's fault. They did have engine problems, but they mostly had flight computer problems that made those problems worse. You just got to think about the plumbing for 31 engines all around a 9-meter diameter circle.
I wouldn't want to write that code.
It's a lot of pipes, right?
Yeah.
All of the each one of those engines needs 2 pipes in, right? Fuel and oxidizer, along with to go to their pumps. Each one of them has a pump. It's a lot of engines.
Yep.
And so it's going to be challenging to make all of that work. And it is big. No two ways about it.
What is the practical application of this, if not to go to Mars?
That's an excellent question. And let's get into that. I got to describe the second stage first, because this is where we get, Elon wants 100% reusability, right?
Yeah.
I mean, that's his goal. And where is he falling down? The first stages, they're reusable, no problem. The second stages, you lose them every time. They're too high, too fast to return. The amount of additional mass you'd need to be able to decelerate it and land it makes it worthless.
Okay.
The Dragons are reusable, although the trunks are not, right? They have now reflown a Dragon V1 back to the space station, which is cool. The design of the BFR has the second stage containing not only the tanks and propellant and a set of engines, 6 engines for the second stage, it's also the payload.
No kidding.
So this is a 2-piece rocket, right? A first stage that's going to boost you to a certain altitude and then fly back and land, and a second stage that finishes the orbit, does the reentry, and also lands on its tail.
And also has possibly people in it.
Exactly. Now, this second stage is also 9 meters diameter, so it is the biggest upper stage you've ever seen.
Jeez.
They expect to have 825 cubic meters of pressurized volume. The space station has 900 cubic meters of pressurized volume. A 747 has about 800 cubic meters of pressurized volume.
That's big.
Like, it's just crazy big, right? If you talk about like the Dragon capsule right now that transports stuff to the space station has 10 cubic meters.
Right.
Takes about 6 metric tons to the space station and 10 cubic meters. The Cygnus, which is the other resupply ship, is bigger. It actually carries less weight, can only take 3.5 metric tons, but it has 27 cubic meters of space in it. Right? It's interesting that volume and mass not the same thing. Right.
So it's not that we're going to use the BFR to go farther. We're going to use it to carry more in one trip to the space station.
We absolutely could, because it should be able to lift 150 metric tons to low Earth orbit.
Jesus.
Now, as opposed to what the Dragon currently does, which is 6.
Yeah. I get it.
So this is kind of, I don't know what you do with 150 metric tons. Like, you've basically got about a third of the entire space station in capacity there.
Yeah.
Right? And volume-wise, you almost have the entire volume. But what's brilliant about this design is, again, we get back to the reusability problems. The other piece that he can't reuse right now in the Falcon 9 is the payload shroud, right? The 2 pieces that split apart, and he was going to try and land them with parachutes. Like, he wants to recover everything. If you have a ship this large, you no longer have a payload shroud. You have a cargo hatch.
Sure.
So you just open up, release your payload, close up, fly back. This is 100% reusable design if it works as designed. And he's saying 150 metric tons to low Earth orbit, 50 metric tons landing.
The space shuttle had a payload hatch, right?
It did. It had this payload bay doors in the back. Now, it wasn't pressurized volume, but you could put pressurized volumes inside of it. And the individual pieces of the space station, many of them came up that way.
Right.
And the advantage of that approach of bringing it up in the shuttle is that you didn't have to make flight-tolerant space station devices. They didn't need to have their own maneuvering systems. They didn't have to tolerate the flight conditions. They didn't get heated or anything like that. They were inside the shuttle safe. The shuttle dealt with all of those forces, and then they were docked in place. They were pulled out and actually placed into where they would connect on the space station. So you're essentially looking at a new ship that's capable of doing that.
Wow. That's amazing.
Right? And what's again, it's so big. It's so much larger. I mean, the space shuttle was 36 meters long. This would be 48 meters long.
Yeah.
So it's enormous, but you don't have to run it full all the time. When it's 100% reusable, the only thing you're really using up is fuel and some maintenance.
Right.
And I was trying to figure out, what the fuel cost would be. Many years ago, Elon said, I did the math, and the cost of the fuel for a Falcon 9 is like $200,000.
Yeah.
And yet the mission, each one of these flights costs $60 million. Like, it's not the fuel that's the issue.
Right.
And interestingly enough, methane, dramatically cheaper than RP1.
Yeah, and if you strap 1 million buckets to the back ends and front ends of all the cows and steers in the world, why, you have an infinite supply of methane.
Well, we have a lot of methane.
Or my
Methane's
Uncle
not
Bud.
hard to come by. So he absolutely could fly this to Mars. It's not as big as ITS. So ITS was supposed to fly 100 people to Mars, maybe even 200. This would be more like 50 or 60. He actually talked about 40 cabins in that design that could have 2 or 3 people in them. So that could get to 100.
Wow. Brings a new meaning to the word pleasure cruise.
Well, yeah, except for that radiation problem and the
details.
Damage in free fall, all those little details.
Little problems.
And he has an integrated landing system. So it's the design here is that it has a heat shield that is durable, that allows it to deal with atmospheric reentry, but then it lands back on its tail again.
Yeah.
If you remember in the ITS show, we talked about the refueling system where they would come up side by side and dock to each other and transfer fuel. And I said, that's the stupidest thing ever.
Yeah.
Like, it's going to be more complicated than that.
Right.
His new refueling system actually has a refueling ship the same size and shape as the BFR second stage, going tail to tail.
Now that's
and then they
weird.
accelerate the ship to actually move the fuel from one machine to another. So to do a Mars launch then with this new BFR, you would fly up with your 40 cabins. You have 150 metric tons. So some of that's put to people, some of that's put to equipment. You then fly 4 refueling ships to fully refuel that ship to be able to fly to Mars and land. It then needs to refuel on the surface of Mars. So you better have a refueling system that works and fly back.
But this is all way in the future.
In theory, it is, right? I mean, what's interesting about the BFR this time is he says this is the rocket that's going to replace Falcon 9 and Falcon Heavy.
Yep.
He wants to use it for everything, which is how he's going to fund it, right?
Yeah.
The big problem with the ITS is there's just no way to fund the thing.
Right.
Right?
Yeah.
So this is a way to fund it by making it the rocket. You just want to lift a 20-ton payload into low Earth orbit? Yeah, we can do that. Because we're 100% reusable, you're only paying for the fuel. So I did the math on the fuel.
Okay.
And the math on the fuel comes out to about 7,000 tons of fuel. Roughly 5,500 metric tons is liquid oxygen, and 1,500 metric tons is the methane.
Okay.
The cost of the fuel for a fully fueled craft then comes in somewhere in the neighborhood of about $1.3 million.
When the cost of a launch is?
Well, we haven't got a price for a launch in a BFR, but a Falcon 9 full thrust is $63 million.
All right. So it's really not that much, relatively.
No. And again, Elon's describing it the same way you talk about airliners. Imagine if you flew an airliner to your destination with just enough fuel that it gets there and runs out of fuel and you have to jump out with a parachute.
Yeah.
And destroy the plane in the process.
Yeah.
Why not fly it so that it has enough fuel that you can completely recover it, refuel it, and run it again? Yes, it'll need maintenance.
Right.
But it's refuelable and it's reusable, so you're not throwing anything away. You're much more practical. So Elon does have a new Mars plan, but he says the timelines are aspirational.
Yeah.
He wants to fly 2 BFRs to Mars in 2022 that are just cargo. So 300 metric tons of equipment brought to Mars to use robotics to set up power, extracting water, building life support, get the water resources set up. And then 2 years later in 2024, fly 4 of them, 2 crew and 2 cargo as the first people on Mars that will build out the refueling infrastructure and will and start the space operations. And I'll include the video and the links in the show. They show a lovely city on Mars being constructed.
And it's not far away.
Very aspirational.
Yeah.
He also shows some videos of them landing on the moon, which
Neat.
is absolutely no reason why this couldn't be used to fly to the moon as well.
Sure.
And, if we're able to do more geek outs, even with as pressurized as I am right now, we should do some more on the moon because the moon's become much more hip. In fact, coincidentally, on the day this show comes out,
The
is
19th.
the day that I am at NASA Ames doing a presentation to the staff about the moon base.
Well, this is amazing. Tell us more about this, Richard.
Well, back in March of 2017, we did a show called The Moon Base Geek Out.
Yeah.
We talked about why humans should go back to the moon, what we could do for us, how we would develop it, how we'd utilize the moon as a resource. And apparently it got passed around at NASA, and we got a call from the NASA Ames Center saying, hey, we really like this, and we'd love if you would come and present it to us.
Yeah.
And I said, I just read your papers and then read it back. And they're like, yeah, but we like the way you read those papers.
Yeah.
So,
And not you said before that not everybody at NASA has the cross-department overview that you seem to have.
I think that's part of it, is that I did bring a lot of elements together.
Yeah.
We've been to NASA Goddard, you and I.
Yep.
And those guys are very focused on space telescopes, right?
Yeah.
They've repaired the Hubble. They're building the James Webb. It's a specialization. And
Right.
I'm very much a generalist.
Yep.
And NASA Ames, these are the guys who flew the Lunar Prospector, the L-Cross mission, some new upcoming missions. They're roboticists.
Yeah.
And so mixing robots and human is a broader conversation around this problem. And
Yeah.
it speaks a lot to what the moon's about. But I find it interesting that since March, when we did that show, and today, the concept of using the moon as a staging ground to go to Mars, to test equipment and to possibly, build up refueling and so forth, has become much more talked about. It's sort of in the headlines right now.
That's so cool.
It's a powerful subject. And yeah, folks are very interested in that.
So cool, Richard. This has been an amazing geek out.
Thank you, buddy. I'm excited. We'll see what comes of that. And yeah, certainly from the context of how we unify all these things, it makes a lot of sense. We're getting long here, and I want to bring up one last thing that's in that video from September of 2017.
Okay.
How Elon ended this 45-minute conversation about what he wants to do with the new BFR. He ended it with, why do we have to fly into space? Why can't we just fly to different places on the Earth with this rocket?
Interesting.
And so he showed a great, animation of people going out on a boat to a pad some distance from a city with a BFR on it, getting on board. It takes off from New York City, lands in Shanghai 30 minutes later.
And the great thing about this video is it ends up saying basically anywhere in the world is only 30 to 40 minutes away from anywhere.
That's right.
Yeah.
So, right.
Yeah.
First thing to be aware of, if you do the math for the 7,000 tons of fuel we're talking about, it's roughly a 10 kiloton bomb. So about half the strength of Hiroshima. So you don't want it too close to your cities.
Right.
Be careful where you fly. Because if it goes wrong, it's really going to be spectacular. It's very noisy.
And by the way, that 35 minutes is just pad to pad. You know, if your pad is far away enough from your city, you have to take a boat there. You have to get to the city. It's still going to be a travel.
Yeah. And you think about, it's like flying from Vancouver to Seattle, right? I don't do that anymore. I can drive it faster. The time it takes to get through airport security, get boarded, 45 minutes of flying, get back out, all those times are going to cost. By the way, the 30 minutes point to point, it's probably double that because re-entry goes slower than launch. And launch is an important aspect of this. Typical acceleration rates for a rocket of this scale, like if you compare it to Saturn V, was 3 Gs.
Wow.
I don't know that I could tolerate 3 Gs for several minutes.
Yeah.
I think, the health aspects are not a small thing. Most people are crucifying it simply around, it's going to be too expensive. But if you think about it, if it can fly 100 people and the fuel cost is about $1.3 million, that's $13,000 a ticket. That's in the realms of a first class ticket on an airliner, which is what Elon said.
Yeah. Wow.
Is it practical? Probably not.
Yeah. I mean, you're going to have a limited number of clientele. However, those people are going to want to get from here to there as fast as they possibly can.
But it's not going to be comfortable.
Yeah.
And it is going to be quick. There's not going to be any bathroom breaks, but you're not going to be flying long enough.
They're not going to serve coffee.
Yeah, they're not going to do any of those things. They're going to strap you in, they're going to fly you there, and then you're going to have to get out.
Yeah.
But you get back to, this is the conversation we had about hypersonics as well, right?
Yeah.
That what's the amount of time faster that you'll put up with discomfort and cost versus if you got $13,000 to spend on a ticket, sit in a lounge essentially with your every whim catered to.
Right.
And, have a nap. Heck, if you spend $25,000, you can get into one of those Emirates A380 suites with its own shower.
Yeah, and that's the funny part about it. It came to my attention with, I think it was a Freakonomics, where Amtrak, I believe it was, or maybe it was somewhere in Europe, but it was a railway that, they had a lot of pressure to decrease the time it takes to get from here to there. Let's just say Boston to New York, right? And so they put in the Acela, and I can't remember exactly where it was, but let's say they put in the Amtrak Acela, which can, in very short bursts through that corridor, go faster. They were really only able to shave off, 15, 20% of the time. And the cost was enormous. And what if they could give everybody free Wi-Fi and a bottle of Dom Perignon served by a supermodel? It would have cost less, and everybody would have forgotten that they were going to be 20 minutes longer.
Exactly.
Yeah.
I've been on flights from Vancouver to Singapore. 13, 14 hours on an airplane in first class.
Yeah.
And at the end of the flight, I was sad.
Yeah.
I didn't want to get up. I was so happy there.
Yeah.
It's kind of madness. And plus, there are no failure modes.
Right.
One of the big challenges they're going to have with this ship is you're mixing fuel and passengers again in a way that they can't get away from each other.
Yeah.
Which means if anything goes wrong, if an engine explodes, you have any of those problems, you're going to kill everybody.
Yep.
Yeah. There are no good failure modes in this particular design. But
it's a good thought experiment, though, to think about the potentials and the possibilities. It is. Yeah.
Yeah. I agree.
And back to, Elon's MO, which is think big, pare it down to reality, and we get the best possible reality we can get.
I tend to agree. I hope he builds the BFR, because in a lot of ways, there's a parallel between the BFR and the 747.
Mm-hmm.
In the 1960s, when they sat down and said, it's time to build a really big airplane.
Yeah.
The 747 was like an alien spaceship. It was so far ahead of its time, but it had the range, it had the comfort, it had the reusability that it changed flying forever. This is the first time I've looked at a rocket and said, okay, now you're bigger than any payload that's immediately needed right now. We'll come up with bigger payloads, but you have solved all of the reusability problems if it works the way you're describing. Yeah, it'll be big, but at 100% reusability, you're talking a few $1 million a flight, right? The price per kilogram is like 11 cents.
Wow.
For flight. The Falcon 9's already blown it out of the water, getting below $2,000 a kilo.
Yeah.
But to get down to pennies per kilo?
Yeah, that's crazy.
That's airliner numbers, my friend. That is really, really important.
Well, I hope he does it. Good luck, Elon. Despite what we've said about you in the past. You are crazy, but
I am enthusiastic. I like his chutzpah. How's that?
Yep, me too.
But I also and maybe this is the one. He is targeting in on something, and the fact that he wants to make just this vehicle and replace everything else speaks to how serious he is about it.
Yeah,
and that might just do the thing we need to do.
Well, thanks again, Richard. It's been another amazing Geek Out.
Thank you, buddy.
All right, we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC. Yes, I'm a